So some of you guys may know the story of Proteus from Greek mythology. He was the guy who evaded capture by continually changing his shape. And I would say that Matt Botvinick is the archetypal Protean intellectual. He started his academic life as an art historian. And then he said, well, that's not what I'm really interested in. What I'm really interested in is becoming a psychiatrist. He went to medical school. And then while he was in medical school, becoming a psychiatrist, he said, well, what I'm really interested in is cognitive neuroscience. So he became a cognitive neuroscientist and sort of along the way casually invented one of the most famous somatosensory illusions in history. And then did a bunch of neuroimaging. And then he said, well, what I really want to do is become a computational neuroscientist and do neural network modeling. And so he did that for a while. And then that sort of went out of fashion a little bit. And so he turned his attention to various kinds of reinforcement learning and Bayesian models and did a bunch of experiments there and had a very flourishing career. And then he said, well, what I'm really interested in is AI and the connections with neuroscience. And so he went to DeepMind and became the director of neuroscience there. And he did all sorts of interesting stuff there. And then you would think at that point, okay, game over, like you found what you're really interested in. But no, he said, well, actually, what I'm really interested in is policy implications of AI. And so he took some kind of partial leave of absence from DeepMind. I don't know what the technical designation was, and enrolled in law school at Yale Law School. So now he is in mid-career a law student again. But that doesn't stop him from thinking about all sorts of interesting theoretical and practical questions about the role of AI in society, and that's what he's going to talk about. So please join me in welcoming Matt Botvinick.
Thank you, Sam. Yeah, it's a little, I don't like hearing my own biography because it makes me feel like I should say, you know, when I grow up, I really want to be a fireman. Yeah, it's great to be here. I have been in student mode for, you know, most of my week for the last year and a half, which has been wonderful, but it's nice to, you know, be an adult for a second and stand in front of a class instead of waiting to get cold called at Yale Law School. And it's great to reconnect with people here, see, you know, old friends and make new ones. So I was joking with somebody before, right before we all came in the room about what it means when a talk has a title that ends with a question mark. Does that mean that the answer is going to be yes? Does that mean the answer is going to be no? And I said that in my experience, it means the question's not going to get answered. And that's the case here. So if you're here to find out the answer to this question, you can leave. I'm not gonna give you the answer, but you'll see it's a question that I'm rather passionately interested in. And, you know, I've been doing work to at least kind of start struggling toward a potential. Cool. So let's get into it. Many of you will recognize Demis Hassabis as the head of DeepMind. And, you know, Demis is a real believer in the transformational power of AI. And, you know, I think it really captures his true beliefs when he says that, in his view, AI is the most important invention that humanity will ever make. And it's a little hard to argue with him because the guy just got the Nobel Prize for work he and colleagues did at DeepMind using AI to solve protein folding, which, you know, is an amazing accomplishment. And then when you look at what's happening even in the more kind of consumer-facing, like commercialized versions of AI, it is pretty mind-blowing. And I say that as somebody who has been, you know, working with neural networks since like the mid-90s. And you know, when I went to graduate school, it was with a bunch of real true believers in connectionism and neural networks. And we all believed that this future was coming. We all believed that neural networks with enough data and enough compute would be able to do all these crazy things. But even with that background, I'm still, like, my mind is still blown on a daily basis. And so this is something that's public, but I don't think a lot of people have seen it because it was just a demo that was rolled at one of Google's kind of dog and pony shows. But It's a project that I'm proud to say I helped get going like years ago at DeepMind, and it's really like, you know, I'm no longer involved in it, but it's really blossomed, and it shows like how powerful these techniques are getting. So I'll just play this video. I think I need to, we were experimenting with this before. I think what I need to do is just, I'm going to turn, sorry, I'm going to be quiet. I'm going to turn on my computer speakers, and I think you'll have to just listen from the computer speakers. There's also subtitles, but I want you to hear the voice. So let's see if this works.
Just tell me when you see something that makes sound. That part of the speaker called. It produces high frequency sound. Yeah, creative alliteration about these. Creative crayons color cheerfully. They certainly craft colorful creations. That part of the code do. Code defines encryption and decryption functions. It includes any encryption code and decode that is a key and an initial ID. Neighborhood do you think I'm in? This appears to be the King's Cross area of London. It is known for its railway station and transportation connections. Do you remember where you saw my glasses? Yes, I do. Your glasses were on the desk near a red apple. Here to make this faster. Adding the cache between the server and database could be. What does this remind you of? Schrodinger's cat. Give me a beta name for this. Golden stripe.
Okay, I mean, so it's pretty amazing. Pretty amazing what these systems can do in terms of visual inference and language processing. My mom loves to call me and tell me the stupid thing that Gemini just did. You know, like, you know, can't add, and I got the name of this president wrong. I'm like, you know, Mom, just wait a couple of years. Like these kinks are going to be worked out. Like the sky seems to be the limit at this point. And so, you know, you can imagine all sorts of hugely impactful applications for this kind of technology, right? For education, accessibility, and so forth. So it's kind of hard to argue against Demis's assertion, and yet I'm going to. I don't think AI is the most important invention humanity will ever have. And in order to make the case for a different form of technology, I'm going to bring in another Nobel laureate, Elinor Ostrom. Some of you may know her amazing work. She studied collective action problems in the real world, cooperation, and how people manage to work together toward common goals and to avoid opportunities to kind of screw each other over that life regularly presents. And she studied this. There was like a game theoretic literature about this, and we'll touch on some of the like kind of familiar points from that literature. But she was interested in like how people manage to overcome the kind of unfortunate social equilibria that the world invites. And she studied this in empirical settings, looking at things like you know, how people share out the water from aquifers, or share out the work that's involved in maintaining and sharing water in irrigation systems, or like fisheries, and so forth. And it is true, if you read her work, that the methods that people use don't always work. They sometimes go wrong. And sorry, I'm not familiar as I should be with this new slide deck, so I may do that a lot, go back. But she was very interested in what the conditions are that allow people to succeed. You know, how do people negotiate agreements that allow them to cooperate? How do people set up monitoring regimes that allow them to sustainably cooperate in settings where that's difficult? And you know, in my view, that's the most important technology, at least the version of it that works. The social technology that allows us to engage in collective action, to cooperate, and not, you know, not screw each other. So what makes this hard, many of you will be familiar with the points I'm about to make, but just to bring everybody along, what makes this hard is that collective action problems in real life often involve kind of temptations not to cooperate. So one classic example is a public goods situation where there's some public resource, a publicly available resource, but in order for that resource to be regularly replenished and sustained, it's important that everybody doesn't like pig out on that resource. And in some cases, people have to contribute to the maintenance of that resource. And there's always a temptation in that setting to free ride, right? To say, well, you know, somebody else can take care of that resource, or you know, who cares about the other guys? I'm sure it'll be fine. I'll just take more than my share, and that hurts everyone. You know, the canonical failure mode here is the tragedy of the commons. I don't know how legible this is, but it's a little cartoon that there's a sign up here that says, these commons are to be used by anyone who wishes. And these ranchers say, oh, great, I'm gonna get some cows and take advantage of this free grass. And there's a lot of grass. I'll just increase my herd by 200 head. And I could double my income if I double my herd. And then all the cattle come in and they eat all the grass. And that's the end. The cattle can't survive because everybody took more than their share. They free rode. And you have this thing called the tragedy of the commons. Another very, you know, canonical setup, again, with apologies to those of you who are, you know, more familiar with this than me, is something called the prisoner's dilemma, where, you know, the cartoon setup is you have two guys who just pulled off a bank heist and they're hauled in for interrogation, and there's this scenario where if they both rat out the other, then they both get 5 years in jail. If they both keep their mouths shut, then they only each get 1 year in jail. But the interesting cases are where one of them keeps their mouth shut and the other rats out his partner. And in that setting, the guy who rats out his partner goes away scot-free, but the guy who kept his mouth shut is in jail for 20 years. And the kind of formally interesting thing about this is that if you assume that prisoner A decides to inform, and you ask, what's the best thing for prisoner B to do? Well, the best thing for prisoner B to do is to inform, because that gets him only 5 years instead of 20 years. Well, what if prisoner A decides to remain silent? Well, prisoner B again should inform. And you can flip this and get the same answer for the other prisoner, which means that both prisoners are going to decide that they should inform, which ends up in the absolute worst case scenario. Okay, now, Eleanor Ostrom's work was like pushing back on this kind of analysis to say, yeah, these challenges may exist in the real world, but evidently there are ways of getting around them, because we do sometimes find ways to coordinate our actions. And so that's where I'm kind of anchoring. You know, this is incredibly important social technology. It doesn't always work, right? We have some spectacular failures confronting us right now with climate change, for example. But when it works, it's a beautiful, beautiful thing. And one of the places where it's most beautiful when it works is in the setting of democracy. So again, democracy doesn't always work the way it's supposed to, but when it does, and you can see the way that our institutions support collective action, again, when it works, it's a wonderful thing. I will admit that I grew up taking that for granted, but I know it. So let's talk for a second about democracy. So you might say, well, where's the dilemma in democracy? Well, just to give you a taste of at least one story about that, I'll tell you a little bit about a study by Barry Weingast back from the 90s. And his argument was that sustaining a democracy requires overcoming a literal prisoner's dilemma problem. And the story goes like this. You have a state that wants to infringe on the rights of its citizens. It's a sort of cynical assumption here about what states want to do. You have to constrain their power because they want to misuse it. And he assumes that you can divide society into two groups, just for kind of formal analysis. Let's call them A and B. And the state can decide to transgress against group A or group B or both. But the interesting case is when the state decides to only transgress against one of those groups. And Weingast posits a payoff matrix here, which embeds a prisoner's dilemma. So just to give you a sense of what this is, the numbers in each of these cells represent the payoff in Weingast's model for the state, group A, and group B in that order. And so you can see from this graph, from this matrix, that if the state wants to transgress against A, then if both A and B push back on the state, then that's effective. That'll block the transgression. The state gets 0. The state fails in its attempt to exploit group A. And both A and B come away fairly well off because they repelled this attempt at subversion. The problem is that if the state only tries to transgress against group A, then B has a temptation in front of it. Because in this model, B can gain something by acquiescing, by saying, okay, fine, you're not hurting me. Go do what you want to group A. And that's, with the rest of the matrix, that's literally a prisoner's dilemma problem. Now, I could point to ways in which this is happening in the United States literally right now, but I won't allow myself to get distracted. Instead, I'll just pan back to the global situation. Like I said, I grew up taking for granted that democracy worked well enough for it to be reliably there when I woke up in the morning. And I'm worried about it. Democracy on the world stage was on steady ascent for years. But then over the last few years, there's been this dramatic drop-off in the prevalence of democratic government around the world. And at the same time, we've seen a dramatic uptick in the prevalence of authoritarian government. It's significant in this slide that it says populist, because of course the populist move, like what defines populism is a rhetoric that makes a distinction between us and them, the real citizens and then those other people. And that's A and B, right? That's Weingast's A and B. So the populist playbook is, exactly what Weingast was trying to formulate. So I'm going to talk about AI. So let's kind of wade into that by just talking about technology in general. Of course, many people have made the case that one reason, I'm happy to take questions, so let me give you 1 second. One reason why we're in this bind is because of technology. Social media, of course, according to many accounts, is kind of fueling these fires, fueling divisions. It's complicated, though. As much as I believe that story, there are cases where social media seems to have done some democratic good, right? I mean, some of you will remember the role that social media played in the Arab Spring. So, social media, at least in some settings, might have a pro-democratic force to it. I'm not looking to make a comprehensive case about social media, but I do want to make the point, following what's referred to as Kranzberg's first law of technology, that technology is not inherently good or bad, but it's also never neutral. Right? So we just have to be very careful about how we deploy technology, how we design it in detail, and really think about what we want its social impact to be. Okay, let me pause and take the question.
Yeah, so the question is, how does Nash's work fit here? Like, does it apply to collective action?
Nash. Yeah, sure. I mean, the prisoner's dilemma example that I gave is, I was describing a Nash equilibrium. And a lot of Elinor Ostrom's work is sort of breaking out of the game theoretic, like the strict game theoretic, like normal form setup to say, look, the simplifying assumptions that we adopt in order to do these analyses are systematically violated in the real world. And it turns out that the differences in the real world are that's where the action is. Like, that's how we get around these problems. It doesn't mean that understanding the problems isn't important, but it also indicates that, the kinds of conversations that go on around these problems are critical. Okay, so Kranzberg's law. So with that in mind, let's return to Demis's assertion about AI. And I just, so when Demis says AI is the most important invention that humanity will ever make, I want to ask, is it the most beneficial invention that humanity will ever make? I want it to be. I work at an AI company, and Kranzberg encourages us to think about this and to think about it very seriously. And so the way that I've tried to think about this is by putting together, 2 Nobel laureates and saying, well, okay, we've got this incredibly powerful technology. I have other thoughts, which are, it's a different talk, and I'm happy to, discuss with people offline. I have many thoughts about how AI is likely to challenge democracy. I'm not a techno-optimist. But I am interested in the question of whether there are things we can do with AI that might be beneficial in this way, that might help us overcome the residual difficulties that we seem to have in solving these problems. Again, Ostrom pointed to our capacity to solve these problems, but she was also very clear-eyed about the frequency with which our efforts fail. Can we do better? Can AI help us? So that's what this talk is about. So I just want to pause and emphasize, and I will emphasize it again, that the work that I'm going to describe was team science. And in literally none of the studies that I'm going to describe was I the primary driving force. I was just lucky to be involved. I do hope that some of my kind of like high-level motivations, as I've already conveyed them to you, had something to do with defining the kind of arc of this, this kind of stream of research. But these are the people who did the really hard and incredible work. And you'll see I'll put up full author lists as we go along. I want to call particular attention to that guy, McKeel, who is right there. McKeel is still a colleague of mine at DeepMind, but he is part-time there and is in a faculty position at MIT Sloan. So I encourage you to talk to McKeel. He's an amazing guy, and he was one of the leads on the work that I'll get to toward the end involving language models. Okay, but I'm going to kind of go chronologically in the sense like this is kind of the order in which we did these studies. And you'll see that we were kind of using the technology that we had available at the time. So some of the work that I'm going to start with was done before the language model revolution. And you'll see that when language models hit the scene, we kind of started to take advantage of them. But before that, we had other methods. So we started by thinking about social media, social networks. And we set up shop in that territory by taking from the literature a sort of simple social network game. So you start with a graph where each node is a human player, and the edges mean that each player is connected with a set of other players. And the connection means that the actions of each player in that connected set affect the other connected player. And so on every step of the game, players choose to cooperate or defect. And I'll define that in a minute, define those terms in a minute. But after that, there's a social planner. And I'll explain what that means in a minute too. And the social planner says, I have a suggestion for you. How would you like to connect with this person? Or how would you like to disconnect from that person? And all the players know is like what those people did on the last round. Okay, so there's nothing more social about this. The players then accept or reject the suggestions. And then we go back to the beginning and we do the cooperate or defect thing. So what does cooperate and defect mean? Cooperate means if I decide to cooperate, then my pool of money, the money that I'm going to walk away with at the end of the experiment, is reduced by 5 cents. But the pool for each of my neighbors, each of the people that I'm connected to, is increased by a dime. So there's something kind of altruistic about cooperating, right? You're taking a hit yourself, but you're giving money to other people. Now, of course, at the same time that you're making this decision, your neighbors are also making a decision. So you're not necessarily going to walk away worse off if you decide to cooperate. You're going to get money from any of your neighbors that decide to cooperate, but that's up to them. And then defecting means you just sit tight. You don't do anything. If somebody next to you decides to cooperate, you get the dime from them, but you don't take it. There's no deduction based on your own action. So you're free riding, right? In the terms I described before. And then you can on the next step, you get to accept or decline each of these recommendations that the social planner is proposing. So the question is there some social planner that can nudge people to cooperate? Because if everybody cooperates, everybody's better off. But there's always this temptation to free ride. And we can see that the temptation is real because if we start off with a static network, so we're simplifying the game in the sense that we're not going to propose adding or removing edges. We're just going to stick with the original network. Things go poorly. Over time, the fraction of the group that's cooperating goes down. People just naturally start to, they cooperate less as time goes by. Yes.
Can you look at a version of this where people can access the kind of businesses whether the couplings?
No, I think that's been done in other papers, but I'm not expert enough on literature to say. Sorry.
So they get recommended to accept or reject, but they still sort of can themselves choose whether to accept or deny the recommendation.
Yeah, I'm just thinking like if the question is, can AI improve cooperation over a baseline of humans choosing their own degree of cooperation, then it would make sense to have humans, a condition where humans also.
Yeah, it's a very difficult problem though for humans. You have a big,
or just
but
locally, just your neighbor. You get to choose which.
Again, I don't know this literature as well as I should, but I would be shocked if nobody had tried that baseline. I'll look it up and let you know. I'd like to know the answer. There are other interesting baselines, though. For example, random recommendations. Things go a little bit better in that case, and maybe this indicates that humans are, have some sense, right? Because they're evidently choosing among these random recommendations ones that that seem to help, at least in the aggregate. Then there are hand-coded social social policies that people have just kind of reasoned about from first principles and then studied empirically. And these do even better. So one example is something called cooperative clustering, where the tendency is to disconnect cooperators from defectors and to connect cooperators. And that helps. But the question is, can AI do better? Like, is there some possibility that we're missing? We just haven't thought of it. But if we could think of it, it would successfully nudge real people to, into kind of a frame of mind where they ended up cooperating more and walking away all better off. And so that's what we investigated in this study. And the setup is quite simple. And it's one that you'll see repeated through the other studies I'm going to describe. We simply trained a neural network here, a graph neural network, using reinforcement learning on outputs that identified edges to add and edges to remove, given the pattern of cooperation, the pattern of connectivity, and the pattern of cooperation and defection on previous rounds. And the objective function was, let's get people to cooperate as much as possible, i.e., let's get people to go home with as much money as possible in aggregate. And so after training this thing on, one interesting detail, I guess, is that we trained it on artificial players, right? We trained up artificial human players modeled on real human players, and that allowed us to iterate in training much more efficiently. But we ended up with a system that could be then deployed with real human players, and the question is, first, did it help? And second, what was it doing? And the answer to the first question is yes. Reinforcement learning, deep reinforcement learning here actually does discover social planning policy that did nudge human participants in this experiment to cooperate more than handcrafted social policies from previous work. So that's good news. What was this social planner doing? Oh, sorry, I forgot I had this slide. So this is just showing that basically everybody went home better off. So the plot I showed you on the previous slide was about aggregate returns. This is showing that across the distribution of players, the closer the colored lines get to the diagonal, the more evenly distributed the returns were over the players in the game. It wasn't like one player went home with lots of money and everybody else was poor. So that's nice too. Even though, interestingly, the algorithm was not trained to produce that outcome, it fell out. So what is the system doing? Because it would be nice if we could understand these policies that AI is discovering, and that's nice for a number of reasons. One of which is we can explain it to people. We can say, this is what the thing is doing that you're interacting with. And that's a satisfying thing inherently for humans using technology. And it also is nice as a researcher to be able to get inside the black box. So it turns out that there's what's going on in the black box here is pretty simple. And what it is the social planner is almost always proposing to connect cooperators who aren't yet connected. And it's almost always proposing to disconnect two defectors. It is 50-50 on whether it's going to connect or disconnect a pair of people, one of whom cooperates and one of whom defects. But the interesting thing is that this pattern changes over time. So at the beginning of the game, there's a very strong tendency for the social planner to add connections between cooperators and defectors. But as time goes by, it flips to the other policy. It flips to the opposite policy. But toward the end of the game, it wants to disconnect defectors from collaborators. Now, and you can understand that sort of in human terms, in the sense that early in the game, you want to try to kind of encourage defectors to kind of get with the program. Here, let me connect you to this cooperator. Maybe that person's behavior will be contagious, and you'll kind of start joining in. Whereas toward the end of the game, if people are defecting, they're just hardcore defectors. There's very little hope for them. And so it's better to just kind of quarantine them so they can't do harm. And one step that you can take in this setting is you can validate your understanding of what the AI agent is doing by hard coding what you think the policy is, right? So I just explained to you in English what all of that is, and I can put it into Python code and then run the experiment again and see if I get the same results, which I do. So in this case, it seems that we're not missing some subtlety of the policy that was crucial, because when we just take the things that we can kind of intuit by eye and implement them in Python, it works the same way behaviorally. So that's a first example of the kind of strategy that would take. So the next couple studies I'm going to describe are in a more economic, more of an economic game setting. I guess the first one was an economic game in its own right, but this is a more classic economic game. And what's at stake here is less that kind of prisoner's dilemma setup and more the public goods. We're going to have we're going to have a pool of resources, and we're going to distribute them to people, and then people are going to contribute to the upkeep of those resources. And this is how it works. I'll tell you about two studies. So here we have this pool of resources. In the study, Raphael called them flowers. But at the end of the study, they could be converted. Each flower could be converted to a certain amount of money. So there was it was incentive aligned. And on each trial in the game, each round of the game, a certain number of flowers, a certain amount of this resource would be distributed to each player. And the amount that was given to each player is the thing that the the mechanism design control. Like this is the thing we're going to learn how to do, is how much money to give to each player. What the players could then do, if they were given anything, is keep some of it for themselves, and that would be converted to money, and then the rest they could put back into the pool. And if they put it back into the pool, there was some interest on that, and that was their way of kind of philanthropically replenishing the pool. If the pool ever went to zero, everybody loses out. The pool is gone. That's the end of the game. And so you can see there are dual incentives here, really. Like you want to store money away for yourself, but you want to kind of try to keep replenishing the pool. But of course, there's always that temptation to free ride. Somebody else will replenish the pool. I'm just going to pocket this money and maximize my returns. And of course, in that setting, you risk the tragedy of the common. So here are some baselines. We're going to let an AI agent do this control this distribution policy in a second. But these are baselines to see like what can go wrong. And things can definitely go wrong. So if you choose a simple policy of taking what's in the pool and distributing it evenly, dividing it evenly among the players, things tend to go very badly. You get a kind of a collapse in the pool. People get less and less reward, and then these down here are individual players, and you can see they just kind of their contributions go down and down and down until the gray zone is a poverty trap. They're not getting anything from the pool. The money's gone. The flowers are gone. So that's a terrible outcome. But that's what people do, unfortunately. Things look a little bit better if you use what we call in this paper a proportional baseline. So here, what everybody gets is proportional to how much they contributed to the pool last time. So if you contribute more this time, you're likely to get more on the next trial. And in this case, things go better in the aggregate. The pool doesn't collapse. There's more reward in the aggregate, meaning like money going to people's pockets in the aggregate as you go along. But you can see things are very unequal. In a lot of games in this regime, one player kind of takes off and starts getting more and more from the pool, while the others are kind of pushed out and end up in this poverty trap. So things may be better in the aggregate, but there's a lot of inequality that comes out of this. So the question is, can we do better? And what would that look like? So we train an RL agent, again, on simulated players, where the simulated players, the simulation of the players is based on earlier data from real players. And the outputs of the RL model, again, are decisions about how much of the pool to give each player. And the objective function is trying to maximize the aggregate reward that all of the players are going to go home with. And lo and behold, a DeepRL system does seem to find a redistribution regime that nudges the human participants into behavior that makes them all better off in the end. So you can see that the pool doesn't collapse, and in fact, it stays higher than in the proportional baseline, and none of the players is falling into a poverty trap. They're all kind of bumping along with some resources to play with. Things look more equal. And so you can quantify these things by plotting the surplus, meaning how much money did people go home with in their pockets, versus the Gini coefficient, which is a measure of inequality across the population. The higher the number, the more unequal things were. So for that equal baseline, where everybody's given an equal portion of the resources, you can see people are going home with very little money. Things are pretty equal, but who cares? Everybody's poor. The proportional baseline, people are going home with more money, but things have also gotten quite unequal. This is just matching the plots that I showed you a moment ago. The RL agent seems to be finding a distribution regime where people go home with a lot more money and without paying a price in terms of inequality. If anything, things are more equal than they were in the proportional baseline. So what's the policy? It turns out that what the RL agent is doing is sort of interpolating between the equal and the proportional policies. So when there's lots of flowers in the common pool, when there are lots of resources available, when the pool is full, then the offer Gini is low, meaning that when there's lots of resources to distribute, the RL agent will divide them up fairly evenly. But when the pool gets lean, when resources are scarce, it goes to the other end and it's much more punitive. That is to say, it only gives resources to people who are really contributing to the upkeep of the common pool. And again, we can play this game where, one more quick comment. We can play this game where we say, well, we think that's what the RL agent is doing. Maybe there's something subtle that we're missing that turns out to be crucial. So let's just hard code that policy that we've extracted from our RL agent and run another round of human experiments with that hard-coded social policy and see whether we get the same result. And we do. This plot basically just says we do get comparable results. Yes, question.
Yeah, I'm not sure I totally understand the setup here. So are you modeling humans? So you build some, you take human data and then you model humans.
Yes, exactly. From earlier rounds of.
And that was true in the earlier experiment.
Yes, yes.
Then, like, so the issue is like, since you're changing like the game setup, why, like, once you're out of distribution, like, are you, like, why do we believe this will hold? And like, on top of that, there's sort of the Pareto question or the equilibrium question. Like, if, in practice, we know that, if things aren't like Pareto optimal, people will just trade to get local improvements. So if the model, like the equilibrium you're finding, if the behavior you're finding isn't Pareto optimal, then, you have reason to believe that, like, both in the short or long term, this is stable. Like, and there's sort of approximation here for people, and then even if there wasn't, if it's sort of not, Pareto optimal, then the longer term, it seems like people would switch.
So in answer to your first question, we don't train the player models under the regime that the social controller is. So it's sort of a we rely on variability. Like we train under many different conditions, and then so it might have turned out that the model player behavior was kind of like tightly fit to those game setups, and therefore using those player models in order to induce a better control policy wouldn't have worked. So that might have happened. Evidently, it didn't. There's no guarantee that the policy that the RL system is discovering is Pareto optimal, and there's also no guarantee that it would continue to perform at the same level if you generalize the game. So, for example, in the social network game, it was 40 steps, and the network knew what step you were on. There's no guarantee that if we expanded it to 50 steps or let players kind of join and then leave, that it still would have worked.
I think it's more the second question more about people's behavior being Pareto optimal. Presumably, because we weren't happy with the first outcome. Like, so in the long term, so this issue, there still could be like an out of distribution problem that maybe people won't behave this way because it's not equilibrium, and then long term, maybe people will just trade and go back to that.
I see. Okay. Well, so the only conclusions we can draw are about the time, the kind of conditions under which we tested. So I'll end with a slide about like the deep challenges of taking this kind of research strategy into the real world, right? And those issues definitely come up there, right? So acknowledged. Yeah. Did I see another hand? Yeah.
When the resources are low, don't we want to give more to tools compared to?
Don't you want to?
Don't we want the algorithm to give more to tools compared to the other agents?
Why would you want to do that?
Like to help them survive.
So there's no problem with the only way in which poor participants fail to survive is if the pool goes to zero, right? Because then there's no prospect of giving them anything in the future. To deprive a poor player of resources on a particular round doesn't have any implications for later. In fact, the thing that like a smart planner would do is make sure that the resources don't collapse, right? So I think that's probably at least a partial answer. Yeah. All right, cool. I'm loving like that I have more than an hour because I can kind of like, go at a leisurely pace. So this is awesome. All right, so all right, this is the second study. Yes.
So when you
Yeah. Did it say again?
switch this ad
So it's study specific. So in the first study I told you about, it's naturally temporal in the sense that the model knows what step of the game it's on. All right. So I mean, it could have ignored that, like that could have just been ignored. But the agent figured out that it was a good idea to nudge people in a way that was dependent on where you were in the game. In this second study, I don't think it was temporally dependent. Yeah, it's you can hide that from you can hide it from the planner, except insofar as the stage of the game is correlated with the other parameter. So I can't rule out that there was some correlation in that sense. Okay, so this next study is very similar, but has a couple of interesting distinctions. One is that it's basically the same task, but cuter diagrams. So this is the same thing in a different format. You've got this public pool, and then each person's being given a certain amount from that pool, and they can decide how much to put back in, which bears interest, and the rest they put in their piggy bank. And the policy that we're interested in is this distribution policy, like how much is given to each player. The workflow here was very similar, but with one interesting footnote maybe, which is that we gathered human data, we trained models of the human behavior in a variety of settings, and then we trained the distribution mechanism based on using these artificial players. Now, one difference here was that instead of maximizing money, instead of maximizing the amount of money that people went home with, instead we let people vote. We would give them two different control policies, and we'd say, which one did you like better? And we hit on that idea because we thought, well, like, how do we know that people really prefer, like, how do we know that it's the most important thing to people that they go home with as much money as possible? Maybe they care about equality. Maybe they'd rather go home with less money and know that the other players, went home with a similar amount. Who are we to say? And so in order to kind of impose fewer assumptions on what people wanted in this game, we just said, look, vote. Like, we expected that people would prefer the money, but we were trying to be agnostic. And then so we had a voting model. We also modeled people's preferences, but then we would also validate that by actually having human participants vote on head-to-head mechanism. So here again, we can look at some kind of sensible baselines. And this is the same kind of plot I showed you before. This is how much money people went home with. This is how much inequality there was. And if you kind of divide things evenly, we see again, people go home with not so much money. Things may be equal, but who cares? Everybody's poor. Or here, libertarian refers to that proportional mechanism. We switch the terminology between papers. It's the same thing. So again, we see that people go home in aggregate with more money, but there's this long tail here, which indicates that in a lot of games, things were quite unequal. And we find again that an RL, a learned distribution policy seems to be able to split the difference between those in a way that allows us to kind of have our cake and eat it too. People go home with a lot of money, and we shorten that tail. Like the number of games where things are woefully unequal is smaller. And in this case, like the dependent measure was how much do people like these policies when we compare them against baseline policies, or in this case against human-made policies. And I won't belabor these slides. The summary is on the right, and the important bar is this one, which basically says, oops, in the aggregate, people preferred the RL agent's policy against a policy that was being run by a human. So the human was told what the nature of the game was and was asked to, distribute the resources in a way that that people would like. Yes.
How are people voting on the RL policy? Like, you have to explain what that policy is. So first you have to know.
No, it's just experiential. So they play the game, and then they play another game, and you say, which game did you like better? And it turns out that people like to have money. So like, it's not really that surprising what we got, but it was kind of nice to know that we could take one step back and say, look, you may care about egalitarianism more than you care about money. That's up to you. Okay. Up here. So, okay, so the work that I've described so far was all done before the language model revolution. And to be honest, we always did kind of feel like we had our hands tied. We were interested in human AI interaction, but like what is the human API? It's language. And so, there was this kind of like tight bottleneck through which our AI agents could interact with humans. And of course, economic mechanisms are hugely important. But when the language model revolution happened, we were like, okay, game on. Now we can study human interaction in a much more semantically rich setting. And it was around this time also that at least I personally and my colleague Chris Summerfield were thinking a lot about democracy and about what legitimate democratic decision-making really requires. And we were thinking about whether AI could help in that setting, which is obviously a language-laden setting. So we were all starting to get interested in something called deliberative democracy, which is a set of techniques that have been worked out by political scientists, social scientists over the past 20 years for bringing people together to engage in political discussions and to arrive at recommendations for policy, public policy, but seeking conditions under which people can engage in informed and constructive debate, rather than kind of falling into the traps that tend to sidetrack and undermine political discussion. And I don't have to tell you what those are. They're all too familiar. These techniques have actually been increasingly popular among governments around the world. Not so much in the United States, but in Europe and Asia and other places. There's a wonderful lab at Stanford called the Deliberative Democracy Lab that does a lot of work in this space. And they show you how many different locales are engaging in these kinds of processes. Some places like Mongolia have integrated these kinds of citizens' assemblies into their law. In order to amend the constitution there, you have to pull together a citizens' assembly. Some of you may know that in Ireland, the decision to legalize abortion was driven by a citizens' assembly, not by politicians. So there's some magic here. And it's catching on a little bit, but there's at least one very important problem, which is that running these kinds of like citizen assembly events is expensive. It's expensive in a number of senses and for a number of reasons. One reason is that you really need very good human moderation in order to keep things on track. And skilled human moderators they don't grow on trees, and you need to pay them. And they're also limited in the sense that it's hard to run these things at large scale. So, if you want to have meaningful dialogue between real human beings, there's kind of a ceiling, at least with current methods, to how many people you can get involved. Like, above 300 people, like, you just have a mob. And so there's a problem there, because if we want to integrate these kinds of processes into like real democratic systems, there's a legitimacy question, right? Like right now, when these processes are run, it's usually the participants are randomly selected. And there's a very, very intense and sophisticated effort to sample the participants in a way that yields a group that's nonetheless representative of the entire population demographically. There's a whole like industry and academic discipline built around. But in the end, you still only end up with like on the order of 100 people. sometimes in a polity that may be millions of people large. So there's an obvious democratic legitimacy problem there that the community that thinks about this stuff is very, concerned about. And that in that setting, people very often mention AI and its potential. So there's a quote here from Eric Schmidt. AI has the ability to scale deliberative democracy and thus help resolve the fundamental tension between deliberation and mass participation. So some of us who are involved in the work that I'm about to describe, we're really thinking about deliberative democracy. But now that I've explained that to you, you don't have to worry too much about those details. Really, you can think about it in a different way, which is we were thinking about deliberative democracy because that seems to be a place where the kind of conversations that are supposed to happen, like in a Madisonian democratic system, where people seem to be able to bring about those kinds of conversations, which is an existence proof that ordinary people, ordinary citizens, with no particular training or expertise, under the right conditions, are capable of meaningful, constructive political dialogue, even despite deep disagreements about public policy and values. So, this puts the lie to the received wisdom that voters are just stupid and ignorant and it's all hope. Democracy is hopeless. Because evidently, there are conditions under which you see something very different. Those aren't the conditions that prevail on social media, but you can bring them about. But they're expensive. And so the question is, can AI help us to create these conditions? And maybe in the long run to scale them up so that we can get more people involved. All right, so that's what this work is about. And I want to say again, the two studies I'm about to describe were led by McKeel and also our colleague M.H. Tesler. And so questions may arise, detailed questions, which I hope you won't mind, McKeel, if I bounce questions that I'm unable to answer over to you. Okay, so the first study was just kind of like a quick proof of concept study. The setup was we gave human participants, like a small group of human participants, a question like, should we lower the speed limit on roads? And then each participant would write down their opinion. They weren't sitting in the same room. They were off at different terminals. And then we would feed each of those individual opinions into a language model that we fine-tuned to aggregate those opinions in a way that would be maximally acceptable to the entire original group. So the goal here was to form a sort of consensus statement, but understand I'm using the word consensus very loosely. It was a paragraph that could span disagreements, right? But the goal was to come together with to bring everything together into one paragraph to which all of the participants would say, yeah, that sounds good. That represents my view, and I don't mind the way that the other views are represented there. And the first question was can you do this, right? This wasn't with the latest generation of language models. And so it was just like a proof of concept. Do we have the technology we need? Does fine-tuning help? And the short answer is yes, that we have the technology we need. At that point in history, fine-tuning did help. The format of these diagrams is, how often did people agree, and at what strength did they agree with the statement that came out? And you can see at the far right, you have strongly agree. And the models that are winning here are the fine-tuned models based on supervised fine-tuning. We find out what summaries people like, and then we use those summaries to train a model, then we iterate, right? And then there are multiple ways of measuring how good the output is. You can, instead of asking to what extent do you agree with this, you can say, how good is this? How good a description of the group's views is. So we're interested in a variety of different measures. Okay, so that's how we got things off the ground. The next study we did is one that came out in Nature right before the election. And it sort of took that same approach and elaborated on it and looked more carefully at the behavior that fell out. So the setup here is a little bit more elaborate. There were 5 participants in each run of the experiment, and they would be given a kind of political question to consider. They would write down their long form opinion. And then again, all of those opinions would be fed jointly into what we're going to refer to as, it says AI mediator here, but we nicknamed this thing the Habermas machine. Some of you know the work of Jürgen Habermas, who sort of like inspired the field of deliberative democracy. And then that system, which I'll describe a little bit more in a moment, came up with a candidate kind of summary of everybody's opinions. And then the way in which this version was more elaborate was there was a second step where all of the participants would critique that first output. This is good, but I think you missed what I meant about X. Or like, I really think you're overemphasizing this other point. I think that should be downplayed. And then on the second round, it was the original opinions, the original paragraph, and these critiques that all jointly were fed into this language model that this composite language model that I'm about to describe, and it came out with another, like a revision. There's like a revision process. Now you could iterate, you could do a third round if you wanted. We just stuck with 2 rounds. And that seemed to be enough to get interesting results. So like, just to give you a sense of like what this looks like kind of at ground level, this is an example of a final statement. And I want to show this not just to give you a sense of how long these were, but how much nuance and complexity and diversity of opinion can be squeezed in to a paragraph like this. I won't read the whole thing, but in general, free childcare is a good thing. But it is important to consider how it is provided and for which age groups. We feel that it is important to offer support to parents in the form of parental leave, and that this should be available to both parents. In addition, we feel that free childcare should be provided from a young age, and that it should be provided in a way that supports children's development and learning, and not just as a child minding service. However, we do not feel that free childcare should be provided from birth, as we feel that you get the flavor. And of course, there was nothing to prevent the language model from saying something like, well, some people in our group felt like this, and other people in the group felt like that. So you shouldn't come away with the misimpression that somehow their consensus was forced on the group. There was nothing constraining against that sort of outcome. Yes?
This is a question to the end. But right now, the objective function is right among the deliberative sample, right? But if this is now passed to a policymaking body, there could be a bunch of things that fall through the cracks. There, like some of these statements are clear, but some of them are more vague. Like childcare should be provided, it should be so that's in a way that supports children's development and learning.
Yeah. So
I'm just wondering, like, is this the right objective? In an end-to-end sense?
A lot depends on how you envision plugging this into the rest of the policymaking system. So the Stanford lab is quite insistent that the right setup is to start and to end with a poll. Like the only output of the whole thing, with all sorts of complex deliberation in between, is you ask people at the beginning, are you for this or against this? And at the end, you say again, are you for this or against this?
But somebody else, so the policymakers create the question, and it's perhaps in a way that it's both unambiguous and links directly to some policy action.
Yes, I mean, you could elaborate and have the agenda setting also be through deliberative body, and that happens in some places as well. But yeah, the important piece here is, the answer to that question is yes, but the important piece here is that the output is something that policymakers could use much more immediately than this. However, there are other settings. So in Oregon, by law, some of you may be familiar with the ballot initiative setup that they have it's much more common on the West Coast than it is here. It came out of the progressive movement, and it's a mess. But the idea was to give citizens like more immediate access to proposing policy, and so you can in places like Oregon and California, you can get a proposition directly on the ballot, even if you're not an elected official. Should we set a limit to property taxes or something like that, and then people will vote on it. The reason that that's actually terrible in practice is that the way that you get these propositions on the ballot is by, in order to do it, you have to get a lot of signatures, like many, many, many signatures. And that's very expensive to do. And there's a whole industry built around special interest groups contracting with organizations that then go out and gather these signatures. And so the whole process has just been captured, co-opted by special interests. And they're very devious, at least sometimes, in the way that they word the ballot propositions. Like they'll word it in a way that like no reasonable person could say no, but if you say yes, then there's some consequence that you couldn't possibly know about that has to do with some regulation that a special interest is trying to get around. And one way that Oregon at least has tried to buffer against this is by saying, okay, every time that there's we run a ballot initiative, we're also going to have a citizens assembly that is going to hear from experts from all perspectives, and it's going to deliberate about the pros and cons of the ballot initiative, and they're going to come out with a paragraph that shares their view on the ballot initiative, and that's going to be on the ballot. It's not binding in any way. You can ignore it if you want, but if you want to know how ordinary citizens, given reliable information, came down on this thing, then you might want to read this paragraph, right? Like that kind of protects against like the certain ways in which special interests will game the system. And in that setting, you can imagine a paragraph like this might be, it might be not so bad, right? Because you're not necessarily trying to tell people vote yes or no. You're just trying to like make sure they don't get deceived by the wording.
But the question raises, I mean, not just you don't necessarily want to optimize the agreement, you want to optimize the end result. Then
Fair enough, right? And I'll show you data in a minute that like there's all sorts of concerns about the kind of like tyranny of the majority or tyranny of the minority. And so the objective functions in all these cases are fraught. Like, and they're fraught not because these are hard machine learning problems. They're fraught because they're hard social, like they're value problems. Like there's no right answer. Right? Like you have to decide what your values are and then work your way back to the objective function. So yeah, my final slide will be like hard problems that don't go away, and one of them is what's the okay, so that's an example. Just a quick word about what we mean by the Habermas machine. And Michiel, tell me if I screw up anything here. So it's not just one language model. It's a kind of it's an ensemble. The first thing that happens is the statements from the participants are fed into a language model that has been fine-tuned to output candidate like summary statements. And the work that like the flow is that we let it output a sample of these statements, say 16. Then we have another instance of language model that's trained to act as a personalized reward model. That is to say, it's used. You feed in a person's personal opinion on the topic, along with a candidate summary, and what the model outputs is, what score do you think someone with these opinions would give this summary? And so that allows you to make predictions about how the participants are going to rank these candidate summaries. And then we have an aggregation function. This is another place where qualitative decisions are being made that could be different based on your values and your preferences. But we use a fairly simple social choice procedure, and we aggregate people's predicted preferences in order to come out with a winner. So like the input-output relation here is just a bunch of individual views go into the pipeline, and out the other end of the pipeline comes a candidate summary. But you can see there's a lot of interesting stuff going on inside there. I'll just speed through this. This is just a more detailed account of that initial very high-level iterative process that I mentioned. So what really happened in the experiment was the participants were given a question, they wrote their opinions, the Habermas machine put out a set of candidates, the human participants ranked those initial statements, there was a winner selected based on their rankings, and then that became the target for people listing their beefs, like saying their critique of that initial one. the original opinions, the initial winner, and the critiques go into the Habermas machine. It comes out with another set of candidates, revisions. Those are ranked by the participants, and then we aggregate in order to choose a winner. And then at the very last stage, participants are asked to choose between that final winner and the kind of like first round winner, so that we can see whether the revision process like really helped. And so what do we find? Well, like some of these, like what we're really interested in is like, can this thing do as well or better than a human moderator, right? Because we're interested in like the possibility that maybe in some other form in the future, we could deploy AI systems to kind of save some of the work of human moderators in these settings. So we brought in people, gave them a little bit of training on what this involved, and said like, okay, you write the summaries and try to write them in a way that's going to make everybody happy. And in that setting, we find indeed the Habermas machine like generally outperforms these, admittedly novice, but nonetheless intelligent and at least briefly trained human moderators. And you can see that at the bottom of the scale, where like strongly agree the rating is higher for the AI mediator than the human mediator. There are other measures that are of interest, like how high quality was the summary. Again, the Habermas machine is doing better than humans. A particularly interesting measure is how important is it to incorporate the critiques, right? I referred to this a moment ago. Like, how important is that second round? And it's evident that it makes a difference. Like, that second round improves the outcome. So it's nice to iterate. And then we looked at a bunch of other measures, looking at things that one would want and things that one wouldn't want from these kinds of paragraphs. And we find in general that the Habermas machine is on par with the human moderators, if not better. So I think, yeah, question.
Social choice theory, like it's tricky, like with, like obviously, like Arrow's theorem, even sure it's like worst case, but there's a surprising sense it kind of holds in practice in interesting settings. So like, how do you get at like the subtleties where like in a lot of the cases it's not obvious what good is, and for deep reasons.
Absolutely, yeah. So
how does since then, like it's not clear we found particularly great ways to aggregate people's rankings. So how do we like?
My answer there is the same one that I gave to Sam, which is that none of what I'm talking about solves that. It doesn't alleviate any of those problems. Like it leaves room for whatever social choice procedure you want to use. So it doesn't constrain your social choice procedure, but it also doesn't dictate it. It doesn't tell you what the right one is. I think in this simple setting, probably it wouldn't have made that much of a difference. But it's a problem that doesn't go away.
I mean, it feels like a little different. Like for example, in a sense, like if you have the mechanism, like if you have the utility function, just do VCG and introduce transfer payments. But here, it's a bit different because you're aggregating ranking. So it seems like it's a little more subtle for how you.
Yes, and it's subtle in a layered way, which is to say that, like you have decisions to make about who's even the right party to define what optimum is, right? So so like this is a really fundamental point because there's a risk with a talk like this that that some listeners might come away with the impression that I'm like a techno-optimist, and I'm just saying, don't worry, Silicon Valley is going to fix all these problems. Like, this is not at all what's going on. Instead, there are very important components to each of these admittedly very simple setups where social values are irreducibly, part of the picture. But, that doesn't mean that AI can't, if you fix the aggregation function, that AI can't help you make good on that, right? Can't work around that in a way that's beneficial. So we may come back to this like at the end, because these are exactly the questions I want to raise. They're very much on my mind. And obviously the work that I'm describing is just like getting this sort of getting this sort of work off the ground. Like, let's see whether we can even do this stuff in a simple case where we're not worrying about those subtle. And we do find, like, it's not just that we find that like stuff works the way we hope, but there are some things that are in fact a little surprising. And I don't know whether the insight gained is about machine learning or about human behavior or both. But it's like, maybe it's like, maybe it is about both. But one thing that came out of this study is that we found that at the end of the process, the participants tended to see eye to eye more than they did at the beginning. They tended to agree in a literal sense at the end. It's not that they agreed that the statement was a good representation of their opinions, but they literally agreed more at the end that like taxes should go down, or or like on some substantive policy view. Now, it's really important to emphasize that that was not in the objective function. Like there was nothing, like the Habermas machine was not trained to produce this outcome. It was simply produced to get people to say, I like that paragraph. That paragraph's fine. But empirically, what we found was that people came away at least slightly more on the same page about the issues. Now, interestingly, we did not see that in a case where we simply exposed participants to the opinions of the other participants. That is to say, the things that the people wrote down at the beginning of the process. Like when we just showed the other participants what their conspecifics in this setting said about the policy, it didn't change anybody's mind. But for some reason, going through this iterative process with language model did. And you can see this at so Michiel and MH and our other collaborators did these beautiful analyses on the latent representations in the language model that kind of showed where the model was in opinion space, basically. And we're able to show that the distribution over that set of representations, in the aggregate data set, narrowed over the iterations, or over the course of the experiment. So like the network tended to converge toward a more unified view of the underlying policy question. Now, that might be like a really bad version of that outcome would derive from bias in the language model. Like you definitely do not want it to be the case that the language model comes into the experiment with a bias to say taxes are too high, and then it suddenly manipulates all of the participants to agree with its a priori opinion. And so the study involved very detailed analyses of the leveraging these latent representations in the language model to show that even if you extracted data to show that the model was biased in one way or the other going into the experiment, the direction of that bias had essentially no influence on the opinions of the participants in the end. So it could have been otherwise, but empirically, that's not what happened. Another thing that you might worry about is that this increase in agreement occurred because of a tyranny of the majority. In other words, somehow the language model managed to silence people with a minority view and managed to do it in a way that like subtly persuaded those minority view participants to just get on the bandwagon. And we did not find that either. In fact, through very beautiful analyses of the latent representations in the model again, what MH Michiel et al. Were able to show is that over the course of the experiment, the paragraph that you're looking at represents the minority view more over time. So which suggests that the way to get the whole group in aggregate to approve of the original, to approve of the kind of group, the group statement is not to downplay the minority view, but to bump up its salience a little bit. So again, not something that the objective function was designed to do, but it's something that emergently happened. So the last bit on this study was a validation step where the experiments that I've described so far were in the usual psychology experiment setting where we were like using prolific and taking whoever wanted to sign up. Obviously, that's not a representative sample of any community of interest other than people who sign up from prolific. And so we did another round of the study partnering with the Sortition Foundation, which is one of these organizations that like their job, the reason they exist as an organization is to use sophisticated sampling techniques to derive random samples from, say, the entire population of Great Britain, but in a way that is that allows you to end up with a sample that's representative demographically along dimensions that you define a priori. And so we had a sample of participants who were drawn in this hierarchical sampling, using this hierarchical sampling method from around the UK. And long story short, we got the same results. So the results that we saw in the first round were not dependent on the particular demographic characteristics of our participants. Cool. Okay. So how are we doing? All right. Great. So yeah, just to wrap up, and then I hope we can discuss things in greater depth. So yeah. So Demis, I don't disagree with Demis. AI is really important. I fully expect it to transform civilization, in good ways and bad. But as someone who works on AI, I want to see whether I can maximize the good. And I think one way of aiming at that is to think hard about human collective action, human cooperation, which is a dicey proposition. Like, we manage to do it a lot of the time, and other times we fail. And if there's a way that AI can help us do better in facing and succeeding in that challenge, I would feel great about that. And so that's kind of what we're up to here. And we're looking at AI as something that actually is not guaranteed to bring a golden age, but rather a very powerful technology that we have to deploy carefully and configure in a way that is based on what we know and what we want about human flourishing. So just to recap, I kind of walked you through a little chronological sequence of studies in which we've tried to, we've asked in various ways this question of whether we can use deep learning and deep RL systems to kind of create conditions that nudge human participants into behavior that in the end redounds to those humans' benefit. And we've looked at that in a number of kind of diverse settings, like social networks, economic mechanism design, and then in political debate. And let me end with, I kind of foreshadowed that I'd like to end with a number of questions and problems. And these are things that I think, these are very difficult questions. So the first one is, what do you optimize, right? We've already talked about that. It's easy to say people like money. It's good that when people have money, so we'll just optimize that. But that may be the American way, but it's not necessarily the right way, and we have to make up our minds. And that's not an engineering problem. That's a question about what the good life is. Another really important problem that hasn't come up yet in discussion is the question of autonomy and self-determination. So I keep saying, oh well, we want these AI systems to nudge people into behavior that redounds to their benefit. But this is kind of the same story that people in behavioral economics have told about nudges, and not everybody's comfortable with that sort of thing, right? It feels a little bit too close to manipulation, right? So where's the line? I mean, you can mitigate the concern by explaining to people what you're doing, but there's a real issue here, and it doesn't go away. There's no way of eliminating. You have to decide what you think is, the right thing to do. So again, it's not an engineering problem. It informs your engineering, but this is a form of work where there's no free lunch. You have to make up your mind about what kind of society you want to live in. Transparency is a closely related issue, right? So clearly, you run a higher risk of illegitimate manipulation and illegitimate persuasion if you're not able to explain what it is this AI is doing, right? And that's one reason why it's at least mildly encouraging that in these very simple settings that that we studied, the the AI system actually came up with something that was human interpretable. Like you know, it took some work, but in the end, you can kind of go, okay, I see what it's doing, and then you can test your understanding by saying, well, let's replace the AI system with like a hard-coded version of what we think it's doing. Oh, okay, it behaves the same way. There's no guarantee that that's going to happen in more complex settings, of course. But at least there's a strategy there for trying to get towards something transparent. A subtly different issue is explainability, right? So what I mean by transparency is, here's the overall, like, let me explain to you the overall behavior of this AI. Like this AI will, distribute resources uniformly when there's a lot of resources, and then it'll be more proportional when resources are, that's like an overall description of the AI. What I mean by explainability is, you just got 5 cents. Here's why. Right? It's more of like, this is the way that explainability is used, like in the AI regulation space. It's like, you just turned down my mortgage application. Why? It's another issue. I get a little frustrated with when this issue is raised in the AI policy space, because my impression is that we don't get those kinds of explanations usually when humans make decisions, right? Like my kids just went through the college admissions process. Nobody told them why they got in some places and didn't get in others. And if we went and asked, they would laugh us out of the office. But for some reason, when AI is making the decision, like, we have very different feelings about it. Now, I'm not saying that that's wrong. People should have the feelings that they have. And if they think AI is very different from human decision makers in some fundamental way, then that's something that we should take into account in our policy making. But let's think it through. But nothing that I just said takes away the importance of explainability, right? If you can't explain why a particular decision was made, you should at least be able to explain why you can't explain. Or why the subject of that decision is not like entitled to a decision, right? Again, these are not engineering problems, but they're ones we have to think about in doing this kind of work. Legitimacy is another question. Like, who's designing these things? Like, I work at Google, but I'm not sure I want Google, running my economy. Like, I'm not sure I want Google, like, doing mechanism design, for the US government. Because there are conflicts of interest, and there are blind spots, and who are they to make up their mind about what the social choice function is that's embedded, or what the objective function is. But it's easy for me to say that like Google shouldn't do that, but who should? Like, is this something that we should like subject to like a vote? Should this be like a topic of democratic decision making? I don't know. But we need to think about it. Like, there's no getting around this deep question. Closely related is participation, right? So this is always a problem in democracy. And even if we do put these things to a vote, we need to think hard about whether everybody who's affected by these kinds of social engineering operations have a voice in shaping them. That's obviously not the case, even outside of the realm of AI mechanism design. But as a democratic society, we need to kind of keep hammering away at this. Like, we need to keep that value firmly fixed in mind, even if we're not living up to it. And that doesn't change when we bring AI in. Yeah, and then finally, there's this risk of techno-solution, right? Like, we need to be really clear-minded about what technology can do and what it can't do. And I do, like, I wouldn't be giving this talk if I didn't think that there was a there. Like, I really honestly believe that if we proceed carefully and thoughtfully, we can integrate AI systems into like the way our society works in a way that benefits everybody, because it like sets up conditions under which we can cooperate and thrive. But there are definitely biases to be considered at every stage. And some of these biases, I think, come from those of us who work in the tech industry. And some of them are like complementary, and they operate on people outside the tech industry. So people inside the tech industry are, of course, too prone to say, let's get AI to do it, right? And people outside the AI industry, I think, are maybe too prone to say, no, don't let AI do that. And in the end, like the bottom line is, in my view, is we need to keep two things firmly in mind. First of all, we need to remember that, like, what our goal is. And if an AI can do it better than a human can, we should take that opportunity seriously. Like, you know, like, let's not be technophobic. Right? But I think it's also important for us to keep in mind the possibility that in the end, there may be certain things we just don't want technological systems to do, even if they can do them better. Like, that's a possibility. You may feel that way. And if you do, I have no reply. That's just a value. So again, it's a kind of a dimension that impinges on engineering work here, but it's not really an engineering question. It's a question of value. Okay, so those are the intractable problems that this kind of work faces. I just want to end again by acknowledging the amazing collaborators who really did most of this work. Again, thank you, Mikhail, for being here. And yeah, I'm looking forward to discussing with you. Thank you.
Touchdowns, but how do you prevent the flip side of what you talked about, where you have potentially problems due to some nefarious Trojan horse?
Trojan horse, what?
Yeah. Like maybe the mediator secretly is trying to.
Right. So you're saying what if people become reliant on this kind of technology, and then some malicious actor introduces a version that is exploitative? It's a very serious concern. I agree. It feels to me a little bit like, you know, like it's very common these days to worry about kids that they don't understand the difference between reliable and unreliable news sources, right? And so, you know, like I think in a future of this kind, we're going to have to know the difference between reliable mediators and, you know, and like mediators that you know, that we have less reason to trust. I don't know what that ecosystem ends up looking like. I mean, we're headed into this world one way or the other, in the sense that, you know, everybody in the AI industry is talking about the agent revolution, right? Like we're about, rather than just having chatbots that we can talk to, the next big thing is going to be agents that can do things for you, right? And you know, in the end, maybe even like buying stocks and putting, you know, making deposits to your bank account and so forth. And, you know, and then you've got a scenario where those agents are interacting with one another. And then you've got all sorts of trust problems that are of the same form, right? So I think we're headed into a world where those kinds of, you know, trust and reliability problems are going to be quite rife. I hope that the kinds of things I'm talking about here are ones that would play out in settings that are regulated, right? Like, you know, like what I hope to do is develop AI systems that can be deployed in like citizens' assemblies. And there, you know, you're working with a trusted partner, like you're working with like a software company that does this sort of thing. So that kind of problem doesn't really arise. But if you imagine like you go on social media and like there's some like buddy that Meta deploys to chat with you while you're on, you know, then I don't know what that world looks like. It's a very, very serious problem. Yeah.
I could also give a quick, so that's a great answer, thanks, Matt. But a quick technical answer is, so when we set up the science study, so the last study, the original idea was to set it up as a game, right? So you have two mediators that play a zero-sum game and are trying to generate a statement that wins sort of the vote of the people according to some social welfare or social choice function. And we didn't set it up that way, but we set it instead up as sort of an inference time, which I guess is now kind of in vogue in hindsight, but as an inference time mechanism where we generate 32 statements, then we rank all of them, then we do the social choice function, and then we get sort of the top statement out. And in that way, each of the participants can go back, look at the 32 statements, look at the ranking that the reward model has given, and inspect if that's actually close to the ranking that they themselves would have given, right? So that makes the whole mechanism, because the mechanism is basically
a generative model with a reward model and a social choice function, make the whole mechanism sort of inspectable in hindsight, and you can see what it actually did, if that makes sense. Well, with RL, pure RL, and just a mechanism that immediately generates a statement, you wouldn't have that.
So, I mean, that wouldn't get around the problem of like genuine manipulation, like where the language model. Yeah. Yeah. I mean, like the first thing that Mikhail mentioned is that there's been a lot of interesting discussion in this and very like adjacent literatures about using kind of like deploying language models in a kind of adversarial way, right? So like if basically if one language model makes a particular proposition to you, the other language model tries to like pick apart that, and like there's some hope there in the sense that if one language model is trying to manipulate you, the other language model can say like, don't believe that because if you go to this web page, you'll see that that's not actually true. So I mean, there might be ways of mitigating these problems, but we face these problems with human dialogue too, right? So like in some way, none of this is new. Yeah.
We were talking about that flower game.
Yeah.
You looked at regimes where there would be some kind of a power imbalance for an agent to come in and make those suggestions. For example, like in pseudo democracy for dictatorships, which look like democracy, like they would never allow an agent to make that recommendation and kind of take away transparency, anonymity, all of those things. You would keep power only with one group of resources. There's a way to model that and think about how one might nudge that system. I even model it.
Yeah. It really got me thinking because I'm quite interested in those issues in my law school life. I'm quite fascinated, by the way, this is a little bit of a tangent, but I'm quite fascinated with the relationship between corporate power and authoritarian power.
Kind of like corporationism.
Yeah, but I'm just sort of fascinated with these billionaires who are cozying up to our leaders now. Like if they went and looked at what happens in other countries that have authoritarian leaders, they would see that the outcome is not good for the plutocrats. So anyway, I don't want to get too political here. Sorry. I do want to get political, but I'll rein myself in. But I haven't thought about bringing those kinds of considerations in to these modeling setups. It's a fascinating prospect, because you might imagine setups where it's about choosing the objective function in a way, right? Like what objective function would an authoritarian choose, right? It would be one that's like deceptive. It would make everybody think that like this is a beautiful mechanism that we have here. This reminds me of a conversation I had earlier with Tomer about how people can kind of game dialogue in order to kind of partially comply with what the other person wants and have plausible deniability. No, but I haven't played with that, and I should think about it more. I think we should think about that more because it speaks to like the social impact goal of this work, right? Like if you're putting out tools that if they fall into the wrong hands can empower people who want to actually undermine real human collective action, and they can use the same tool to do it, then you're basically falling into the same trap that like a lot of AI, honestly, I think is falling into.
Well, Chomsky's like false consensus.
Right. Yeah. Yeah. I hadn't thought about we've thought about a lot of failure modes that can occur and like making sure they're not happening here, but I haven't thought about like truly adversarial setting. And this is a great topic.
So I think we were just to end at the floor.
Okay.
But maybe we can stop here, and if people want to ask more questions.
Great. Yep.
So let's
Thank you very much.